Alrighty, today we're starting on Unit 5, which involves algebraic equations, or all that solving for x stuff you've seen in the past. Now, eventually we're going to get to some crazy problems with all these steps and all these powers and all this amazing stuff. But today we're starting at the very basics by asking the simple question, where do equations even come from? So, to make sure you remember, equations are any sort of math sentence, any group of letters, numbers, whatever, that has an equal sign. So, for example, I have something extremely simple like 4 equals 4. 4 equals 4 is technically an equation. Now, we can say something very true about this equation. This is a true statement. It's a true statement. It's true because 4 is equivalent to 4. They're the same thing. Equivalence means that two ideas equal each other. Or are the same. Equivalence holds with any pair of numbers. 6 equals 6. Those are equivalent. 10 equals 10. Those are equivalent. 20 equals 20. Those are equivalent too. They equal each other. They're equivalent. They're the same thing. Now, we like equivalence. We need equivalence for everything we're going to do from here on out. So just know that it's something you want. The cool thing about equivalence is that it holds even if you manipulate the equation. We can perform operations on both sides of the equations. And it will remain equivalent as long as we do the same thing both times. Again, we want equivalence. Okay, so let's take that 4 equals 4 again. I could do anything I wanted to this equation, as long as I do the same thing on both sides of the equation. So, just to mix something up, let's do 2 plus 2. I'm going to write my plus 2 under both of my 4's because I'm doing the same thing on both sides. I want my work to be really clean, so I'm going to do 4 plus 2, 4 plus 2. Well, that's going to be 6. I'm going to put my answer under my work. I'm going to bring my equal sign down, and I'm going to do the same thing on the other side. 4 plus 2 equals 6. Okay, these are still equivalent, so I'm still good. I did the same thing on both sides. Moving on to 2 equals 2, I can do something else, whatever I wanted to. Let's say I want to multiply this by, let's do multiply by 10, just for the fun of it. Remember, I could do anything I wanted to as long as I do the same thing on both sides. I put my work under my numbers. 2 times 10 is 20, equals 2 times 10 is 20. These are still equivalent, it still works. Next one up. I got 3 equals 3. This time, let's do subtraction. Let's just say subtract 2, subtract 2. The most important thing is I do the same thing on both sides. 3 minus 2 is going to be 1. Bring my equal sign down, and my 1. Answer below my work. Still equivalent. And I can do this multiple times. I can do this with multiple steps. Okay. Let's say I want to start by dividing both sides by 2. Okay, since I'm doing the same thing on both sides, my answer will be 5 equals 5. That's equivalent. First step done. I could do as many steps as I wanted to, but I'm going to do one more step. Let's subtract 2 from both sides. Minus 2, minus 2. I have 3 equals 3. Answer under my work. Equivalence is maintained. We did everything right. Awesome job. Now, I want to show you what will happen if we don't do the same thing on both sides. We will lose equivalence. And I'll show you what that means. Let's say, for example, I added plus 2 on this side, but plus 3 on the right. Oh no, that's not good. Because when I add 2, I end up with 4. But when I add 3, I end up with 5. These are no longer equivalent. They're no longer the same. I made a mistake. I lost equivalence. Over here, let's say I multiply by 2, but then on the right, I divide by 2. Because I'm doing that, I'll end up with 20 equals 5, and it's no longer equivalent. I messed up. I want to maintain equivalence, and to do that, I do the same thing on both sides. Okay, so your takeaway is that equations remain equivalent as long as you do the same thing to both sides. Now, I want you to pause and take a second to do the checking understanding. Answer these two questions, and when you're done, you can flip to the back. All right, now we're flipping to the back, and we're throwing an X in there. We're going to do the same thing as the front side, but this time use an X. So instead of 4 equals 4, I'm going to do X equals 4. Same thing, just an X. We can read this as X is 4, which is true. X really is 4 because we're saying that these two ideas are equivalent. We would use this sort of logic when we do replacement, right? We're saying that X is 4, so wherever you see an X, you put a 4. This is where our solve for X equations come from. Those solve for X equations you've done in the past come from these simple X equals. We take a simple idea like X equals 4 and add operations on both sides, just like we did on the front of these notes. This time, we just do it with X. So, for example, let's take X equals 4 and add operations. So, let's say I want to do something simple. Just making up something random, I'm going to add 2 to both sides. I'm going to do the same process as before, but now I'm going to do 4 plus 2 is 6. But you'll remember, I can't add variables and numbers. The best I can do is say X plus 2 equals 6. And wouldn't you know it, this looks a lot like your variable equations you've done in the past. X plus 2 equals 6 is something you can solve for. And we built that up from just X equals 4. We got a more complex equation from just adding operations to something simple. Okay, moving on to the next one. I might decide I want to multiply by 5. So I'm going to multiply the left by 5 and multiply the right by 5. 2 times 5 is 10. But I don't get a number out of 5 times x, so I just get 5x. 5x equals 10. This is a complicated equation that comes from something simple. Remember, as always, I'm keeping my work organized. My multiplication stays under my numbers, and my answers are below. Okay, this time I might do some subtraction. So, subtract 2, subtract 2. Again, random operations. 3 minus 2 is 1, but on the left I can't subtract 2, so I end up with x minus 2. X minus 2 equals 1. That's another equation for you, and it comes from doing extra operations. Finally, let's do one with division. I'm going to just divide both sides by 2. Randomly. I can do whatever I wanted. 10 divided by 2 is 5. I bring down my equal sign, and I can't do x divided by 2, so I bring it down. X divided by 2. Okay, that's another equation. Just like the front, this only works if you do the same thing to both sides. So if I did something weird, like I did plus 3 here and plus 4 there, I would get some kind of equation. So I have x plus 3, and then equals 2 plus 4 is 6. I would still have some kind of equation, but these two equations are no longer equivalent. Equivalence is broken. Because that equivalence is broken, I can't do anything with these two. That's useless to me. Same thing here. If I multiply by 3 here, but I divide by 3 there, I'll get something like 3x equals 3 divided by 3 is 1, but equivalence is broken. This won't help me at all. I need to make sure I do the same thing on both sides. And I don't want you to forget, when you're performing operations on both sides, do the work under your current line to keep track of each operation. So I want you to do all your work down from line to line. Okay, here's our takeaway. Algebraic operations come from taking an x equals and adding extra steps. They're nothing scary, they come from a simple place, and they're easy to get to. Okay. I want you to do this checking understanding, and then let me know when you're finished. We'll look over your answers, and if you're ready, you can take the formative. Otherwise, I'm going to want you to do some practice. Thank you very much, and have a wonderful rest of your day.